Hello, fellow chemists. Jolly here. We are going to continue the discussion on Lewis structures, but this piece is going to be specifically to valence electrons. Now, I have my periodic table up here, but what I'm looking for is valence electrons. Now, remember, valence electrons are the ones in the outermost shell. They're the ones that are available to react. So those are the ones that I'm interested in. Now, when you look at the periodic table, we are looking at the valence electrons, which are the outer shell electrons. So I'm not caring about underneath, but again, this is going to be for Lewis structure, so I am only interested in the non-metals and the metalloids. So we're only interested in pretty much that side of the periodic table. All right, now the way that you figure out what the valence electrons are is you go to the top of the periodic table and you find the column number, and instead of a 13, you get rid of the 1, and it's 3 valence electrons. So this one has 3 valence electrons, 4 valence electrons, 5, 6, 7, and 8. Now, where do those valence electrons come from? That is from a past discussion, but really briefly, we'll just look at carbon. So carbon has an electron configuration of 1s2, 2s2, 2p2. Notice these are in the n equals 2 shell. The other one is in the n equals 1 shell, so this is the only thing that I can play with. So carbon has 4 valence electrons. Those are the ones that I'm allowed to use. The same could be said of all the others. So all of these are in the n equals 2, the n equals 3, the n equals 4, so forth and so on. And then, of course, hydrogen and helium would be in n equals 1. So those are the valence electrons. Now, if you're going to be using those valence electrons, we're going to talk about three-dimensional space. And how many spaces can you get on a flat board? So if I was to draw carbon right there, there's 4 spaces. There's 1, 2, 3, and 4. So basically, I'm going to put those electrons in those 4 locations. Keep in mind, this is a 3-dimensional atom that I'm trying to draw on a 2-dimensional picture, but it works pretty good. All right, I'm going to clear this out. And we are going to play with the valence electrons for the ones that you will most likely be doing. All right, so let's take a look at hydrogen. If you look at the periodic table, hydrogen has 1 valence electrons. Now, you could put it there, you could put it anywhere else, okay? You could put it in any of those other locations, but that would be for hydrogen. For helium, now helium is an interesting case because it is a noble gas, which means it's complete. So instead of doing this, I would actually put them both together because it is a noble gas and it is filled. Boron comes next. 1, 2, 3. I could have done it this way. 1, 2, 3. Any variation works. Carbon comes next. 1, 2, 3, 4. All right, now notice I've just used up all 4 locations. So the next time I'm going to have to start pairing electrons up. So after carbon comes nitrogen. 1, 2, 3, 4. There isn't a location left, so I need to start pairing up. Oxygen, 1, 2, 3, 4. Gonna have to pair up 2 of them. And fluorine, 1, 2, 3, 4, 5, 6, and 7. And that's how you put the electrons around the nonmetals to figure out where we're going to bond to. So that is called the valence electrons, and that is how you would draw them. Now, I use the terminology bonding places. So how many good bonding places do each of these atoms have? And for me, a bonding place is a loner, is a lone electron. If they're paired, this is called a lone pair, and those are not available to easily make a bond. All right, so how many good bonding places does this boron have? It has 3 good bonding places. How many does carbon have? It has 4 good places. Nitrogen, okay, now it seems like I should say 5, but I'm not going to. Nitrogen only has 3 good places. Oxygen has 2. Fluorine has 1. Now, if I was to draw neon, it would look just like helium, and it would have no good bonding places. So, in order to form a bond, you have to combine electrons, and a covalent bond is sharing. And to make a bond, you have to have 2 electrons. That would be called a single bond. If you have 4 electrons shared between the same 2 atoms, that would be a double. Or if you have 6 electrons shared, that would be called a triple. Alright, but this is how you figure out the valence electrons and the bonding places, if you will. Alright, until next time, jolly out.